First of all, I look out here and I would like to thank all of you for your loyalty and patience in this whole CGI game. It's been very, very interesting for us. We're a pretty old company, really, made up of a lot of things I'm going to show you in a few minutes, but we've been working on building car engines and truck engines since they were invented. Most of our companies are close to 100 years old or older, and we've been doing this a long, long time. We are a truly global machine tool manufacturer, as you're going to see in a minute, and we spend a lot of time working on technology. I'll tell you a little bit about the cost of that in a few minutes, but we have 26 facilities, 17 are production plants. We have about 3 million square feet of manufacturing space, 4,500 employees, and we do about $1.5 billion a year in sales, and it's all in machine tools. We think, about the fourth largest manufacturing company in machine tools and metal cutting. And if you look at these three companies, you'll see that if you recognize them, you'll know that not a lot of their revenue is generated on the automotive engine side. We are unquestionably the largest company in the world, especially in the area of heavy-duty truck engines. This is the way our company is set up. We have 5 main operating groups, and the 6th is our international group. The reason we established this international group, although it sells and manufactures the products seen in the other operating groups, basically the growth rates are different, the customers are different, the market segments are different. So we broke out the international side because we have a lot different strategies, for example, in India than we have in the United States or the North American market. Here's some of our brands. I don't know if any of you are in the business or not, but if you are, I'm sure you'll recognize some of these names. They've been around a long, long time. We cover the world. As Tarquino said, today you have to be a global player, and we operate in every country in the world that manufactures engines. You can be sure that we're there. Our major products, markets, products, and applications: automotive, aerospace, heavy equipment, general machining. Anywhere that metal is cut, we're there. Automotive is the largest part of our business. Today we do, I would say, probably about $800 million a year in automotive, and then the rest of it about $700 million. Let me give you a little history. I have some notes here I'm going to refer to because I don't want to get off on the time. Our first lesson we have up in the upper left-hand corner. This was the first time we tried to machine CGI. And this was an Audi transmission case that Balo was making. We lost $1 million on this job. We looked at the CGI and said, hey, this stuff looks like cast iron to us. Make a very long story short, at the end of the job we had to give them a free machine and a free assembly system because we were so far off on the cycle time for processing CGI that they ended up with a very nice line, and we ended up with our first lesson. This was our beginning tuition, and I got the guys together at the time and said, that's not going to happen again. I like this material, but we're going to learn how to machine it. So we began our lessons really in the year 2000. And I have to tell you that this industry that we're in is extremely risk adverse. In other words, the common line that you receive when you call on an automobile company is, oh, you have a new idea? That sounds great. Tell me somebody that's been using it for 3 years. Let me see how they've done, and then maybe we'll try it out. So if you think that introducing a material like CGI into the automotive industry is a simple task, believe me, that is about the furthest thing from the truth. Remember, this is now 2007, so just our part of it, we're looking at about an 8-year odyssey, really closer to 10 if you count the tuition in. And you can see here on the chart that we have SinterCast in there because as we pursued CGI and the machining of CGI, we discovered SinterCast and looked at their process. And one of the things that you'll find is that when you are a systems manufacturer, as we are, we basically deliver a solution to the customer. They come to us and say, you know, we're going to make a block. Here's what it looks like. You guys devise the system, and here's the tolerances we want to hold, and then we put the whole thing together. And that means that if in the end it doesn't work, it's like the Balo case, we end up paying for it. So we're very careful when we design new systems. And when we came across SinterCast and we realized that we could count on the quality, consistent quality of the product that went into our machines, we very quickly latched on to Steve and your company, and we haven't let go yet, and I don't plan on doing it in the near future. We entered into the technology sharing agreement with SinterCast. And when we did that, we began a series of briefings worldwide to our customer base. And I didn't put our chart up here, but if you can think of a company that makes trucks, we sell them stuff. That includes Russian, Indian, Chinese, American, you name it. We have 3 brand new lines starting up in China right now, all 11-liter lines, none of them CGI. But I will tell you that we have personally briefed every technological center in China that has responsibility for automotive on CGI. And as soon as Steve can get their foundries whipped into shape, I think you'll begin to see them casting in China. In 2001, we won our first major CGI contract. If you look over there in 2002, it shows you the Ford V6 Lion prototype. We won the contract in 2001. This is the first high-speed, high-volume manufacturing line making CGI blocks. It was a lesson for us. We had a few problems, not many, because we'd spent a lot of time and money on research. And this V6 engine is now in all of what they call the PAG automotive group vehicles. This is the premium automotive group vehicle. So Earl has it in his Land Rover, and if you have a Jaguar, you also have it in your Jaguar. They were planning on selling some to Peugeot, and I think they are now doing that. They backed out in the beginning, but since then the volumes have greatly increased. Okay, so for the last 7 years, we have promoted the CGI technology. And we've done this basically by promoting SinterCast. We have been in a technological partnership with SinterCast, and I'll just take a moment because I know the anecdotal things are sometimes as interesting as the actual technological stuff. But one of your customers is Hyundai, and I am going to claim total responsibility for that. Steve helped me a little bit, but basically I was in a meeting and we were talking to them about CGI, and they said, well, you know, we're going to manufacture a CGI engine. I said, oh, terrific. What technology are you going to use? They said, well, we're our own foundry says that they're going to make it using their technology. So I said, okay, you Koreans are very good at taking notes. I want to dictate something to you. I want you all to write it down. I said, the first thing that's going to happen is you're going to get a sample of blocks, and there's going to be maybe 20 or 25 blocks. And you're going to cut the first block and everything's going to be fine. And then you're going to cut the next one and half your tools will break. And most of your inserts will wear down. And you'll say, you must have made a mistake. You'll check your feeds and speeds, maybe slow things down a little bit. Then you'll cut the next block, it might do all right. Then you'll cut the next one, might do all right. Then you'll cut another one, and all of a sudden your tools will break and all your inserts will crack. And after you've done this for a while, you'll get together with the foundry and your boss, and you'll say, there's a problem here, and the foundry will very clearly tell everyone in your company that you don't know what you're doing and that you just don't know how to machine CGI, and that's the problem. Depends on how quick you are, but basically one day you'll take one of these blocks out and you'll cut it in half, and you'll find out that you're trying to cut nodular iron because the foundry is unable to control the process. And to them it will be a great mystery as to what comes out the other end, whether they're pouring real CGI or whether they're pouring nodular iron or something even harder. So they went off and started. About maybe 6 months later or so, Steve floated by and said, by the way, I got a contract with Hyundai. And shortly after that, I got a phone call from the director of engineering. And in his broken English, he told me that the scenario worked exactly the way their notes said it would. And believe me, this is the whole difficulty with CGI. It is a different material, and as I told you earlier, and this is something you have to remember, and it's something that as a company you have to overcome, and that is the fact that you are selling into the most reactionary industry in the world, which is the automotive industry. People get promoted in automobile companies by not making mistakes. They do not get promoted by being innovative. Now you say, oh, there have been a lot of innovations in automotive, but if you go back and check them, you'll see most of them have already been used someplace else, so they know by the time they buy them, they work. And you're in the position of trying to introduce new technology to an industry. So while, as I said earlier, I basically thanked you for your patience, let me tell you what's happening right now. In 2006, first let me explain. We do something called simultaneous engineering. A customer will come to us. Let's take, say, Cummins as an example. We have a partnership agreement with Cummins. We build all of their machines. There's no competitive bidding whatsoever. Unlike General Motors, where they buy the cheapest thing they can find, except in the case of machining of CGI. I won't tell you any more about it other than the fact that they're using our process and SinterCast process. But generally speaking, these guys are going to come to you as a company and say, we've designed a new engine, you're our partner, help us design the most efficient production line. And if you have any time, go look on the internet, look up Cummins engine, check their profitability, and you'll find that they beat everyone in the world in terms of profits. They're a very conservative company, but they have learned some paths they've taken, as they would say in the Buddhist countries, they have found the path to enlightenment. And that is, do what you do best and ask all of your suppliers to do what they do best. So it wasn't too long ago that Cummins came to us and we began a simultaneous engineering program for the design of a diesel engine manufactured with CGI. We started 2 of those projects in 2006. We started 2 more in 2007. And in 2007, we received 4 orders for CGI blocks. Those are the first major orders in North America. I will take issue with one of Takeno's slides where he shows the heavy-duty pickup truck market using gasoline engines. I will make a bet with all of you now that the entire next generation of engines for pickup trucks will begin to switch back to diesel. Right now, a large percentage of pickup trucks in the United States use diesel engines. Chrysler uses Cummins engines, Ford uses International engines. General Motors now has their own engine, which was designed by Isuzu. They all now have common rail injection systems, and they've quieted down maybe 30 or 40%. With the new technology and the fact that the United States now has gone to 15 parts per million of sulfur in the diesel fuel, which is a major change. You're now going to see diesel engines in the United States that are the same as the ones in Europe. And it is my opinion that we will see a tremendous acceleration in the use of diesel engines, and the majority of these engines in the pickup trucks will be compacted graphite iron. I don't think there's any question about it. As I said, the proof is the fact that we have 4 orders this year, and they are major orders. These are not prototype orders. These are full production orders. I would say they represent probably 16, maybe, I'm
You
not?
don't have to give a number.
Very large numbers. Okay. The point I want to make is that these are not experimental production lines. These are full production systems. So the decision's been made by the OEMs that CGI can be machined economically. This goes back to the point I was trying to make to you earlier, that because they are risk adverse, it takes them a long time to make up their mind. But once they're convinced that there isn't any risk, off they go. In one case, they're hedging their risk a little bit, and you'll know about that in about 6 or 8 months. Also, we have Don Norberg here today, and Don has worked with us for a long time on trying to develop some tools to help us bring the machining times for CGI to the same level as cast iron. And he has a new tool under development that we're going to start testing in our Port Huron facility here pretty quick, which will allow us not only to do face milling, but also to hopefully do some cylinder bores. It's very tough to machine CGI cylinder bores because of the temperatures that you generate in cutting the material. I think that once these 4 projects that we have going now come into production, you will see a great rush by the competitors in the business to be able to manufacture out of the same material. And Steve's probably told all you guys over and over again about the superiority of CGI in terms of strength and being able to reduce weight and all the things that it does. And the only thing that has really kept it from being utilized far more fully than it is the fact that everyone thought that it was more difficult to machine. It just took us a while to figure out to do it. Today you've listened to Tarquino, and now unfortunately you're having to listen to me, but basically we are the largest factors in this business in the world. And I mean by a long shot. I think if, as Steve said, if you took everybody else in the world and added them up, none of them wouldn't even come close to the amount of truck engines that we machine on our equipment. So we are fully committed, and I hate to pat him on the back again, but you know, a lot of this work that Steve has done and the travel that he's doing on your behalf and the presentations that he makes, this is what's bringing the OEM community around to the point of being able to take on the use of a new material and absorb the risk, because they're becoming educated. And we're starting the process now in India. We have not installed any lines in China yet. The Indians may beat them. The Indians are frantic to be able to compete with the Chinese, and that's going to be a big benefit for us. As we look at the people that have been involved with us, I think it's important that you understand that when someone like Comet, which manufactures tooling, decides to make a major investment, it's because they're convinced that the future is going to hold some revenue for them to be able to machine this type of material. And you look at these names up here, everybody that we've worked with has been involved in this for a long time. And recall that Ford was the first one, and Ford is not exactly an adventurous company, but they became, when we convinced them that we could machine this, they began to make the PAG engine on here, the Ford Lion engine. And they are also going to make an even bigger commitment, which you will see shortly in the marketplace, utilizing CGI material. Now in 2007, I just want to tell you that our main effort is CGI high-speed machining. We're going to make a lot of noise about how you machine CGI at the same rates that you machine standard gray iron, cast iron. Right now, we're at about 80%. We're going to bring that, we think we'll bring it to 100%, if not by the end of this year, surely in 2008. Here's a picture of a tool that Don's company makes, and this is the insert right here, and that insert rotates as it cuts. So instead of using just the point of the insert, which is pretty common with standard carbide type tools, this uses the entire edge, 360 degrees, rotates as it cuts, keeps the part cool so you don't get heat distortion. And these pictures are on here only to illustrate to you that when we're working with CGI, we do our research in microscopic, using microscopic methods so that we can see the actual cutting of the material. And I'm sure Steve's told you over and over about round carbide versus sharp edges and all of that, so I'm not going to get into it, but let me tell you, we've learned an awful lot about this, and we are working, spending our money now on optimization of the cutting processes. This year is, to me, the watershed year for you guys, because when we start getting orders the size, and by the way, you know, when I talk about selling engine lines, we're talking about somebody investing $100 million at a crack. This is not a $5 or $10 million investment. These are huge investments that these companies are making. So, and maybe that's one of the reasons why they're reactionary and one of the reasons why they're risk adverse, because when they take a step, it's not a baby step, it's a big step. And you have 4 of these steps that have been taken this year, and I'm sure we're going to see a lot more of them next year as well.